Hello YouTubers and welcome back to mathematics. In today's lesson we're continuing with our topic of sequences and series, and we're going to be looking at a thing called a arithmetic series or an arithmetic progression, or an AP. So that's what we're going to be talking about today. So this is on page 7 in that new booklet that I've posted up online, or if you've managed to get a physical copy, that is on page 7. So an arithmetic sequence or arithmetic progression is defined by the following, and of course it's glitched again. An arithmetic sequence or arithmetic progression is defined by the following. So this is how we can define a arithmetic what an arithmetic sequence or an arithmetic progression is. So algebraically, it's Tn minus Tn minus 1 is equal to D, where n is greater than 2 and D is a constant known as the common difference. So what is this talking about? Well, if you recall from our general sequences terminology, notation, Tn, that's just the nth term in my sequence, and Tn minus 1, well, n minus 1 is just 1 before it. So if I take my my current term and subtract it by the term before it, it gives me D for no matter what number is in my sequence. And so this actually means that when we've got an arithmetic progression, every time we go to the next term, we just go up by the same amount. So for example, an arithmetic progression could be, for example, something when if I start off with 1 and the next term was 3, then I go up by 2 every single time. So 5, 7, 9, 11. That's an example of an arithmetic progression. Or you could go up by like 5, for example, 1, 6. We could actually start on a different number. We could go 11, 16, 21, 26, and so on. These are examples of arithmetic progression. So if I take any term in my sequence and I subtract it from the term before it, it gives me this common difference. So it goes up by the same amount each time. So an arithmetic progression is just a sequence where it goes up by the same amount each time it goes up in my sequence. So here, D is a constant value, so D doesn't change. And here, D is also called the common difference. Now with our arithmetic progression, our arithmetic sequences, there's a bit of notation. We often call our first term, T1, we call it A. That's just a bit of notation that we use generally. Okay, so if we want to get the nth term in our arithmetic progression, there's a way that we can actually derive it. So here, if I start from my first term, T1, that's A. So if I want to get to the second term in my sequence, when this loads, great. If I want to get to the second term in my sequence, well, all I need to do is take my first term and add that common difference. I'm going up by that same amount each time, so add D. So that's just going to be A plus D. Okay? Then if I want to do term 3, well, I start off with term 2 and I add my second term and I add on that common difference again. So here, T3 is just going to be A plus 2 lots of D. And the third one, term 4, my fourth term is going to be term 3 plus another common difference. So it's going to be A plus 3D. Now if you have a look here, there's actually a pattern that we notice between the term number and how many D's we need to add onto it. So here, what we notice is that, well, the number of times we multiply D is just 1 less than the term. And so for our arithmetic progression or arithmetic sequence, if we want to find the nth term in our sequence, that's just going to be equal to A plus n minus 1 times our common difference. And we're going to use this fact to help us out in some of our questions later on. So arithmetic progressions, that's just when you have when you go up by the same amount each time. So going up by the common difference every single time. Or you could go down by the common difference as well. Okay, so if we want to prove that a sequence is an arithmetic progression, the way that we do this is we take any two terms. So here, what we have here is, if we want to prove that a sequence is an arithmetic progression, T3 minus T2 is equal to T2 minus T1. What we want to show is that for any term in our sequence, if we take two consecutive terms and we subtract them, the common difference is always there. And so here, this value is just what D is equal to. This all just happens to equal to D. Now here, notice I've written this T3 minus T2 and T2 minus T1. If you don't get the first 3 terms, if you get any like random like numbers of terms, as long as you take 2 consecutive terms and subtract them, and you get that common difference and show that for our sequence, then it's an arithmetic progression. So let's have a go at a couple of examples of this. First one, example 4. Show that the sequence 200, 193, 196, and so on is an AP. Then find the formula for the nth term and find the first negative term. Okay, we actually got 3 things we want to do. Firstly, we want to show that it's an AP. That's the first thing we want to do. The second thing is then we want to find a formula for the nth term. So using this formula up here, we want to find a formula for the nth term. Then the final thing is we want to find the first negative term. So here, we actually looked at doing this we've looked at this last bit in the last lesson as well. So the first thing we want to do is we want to show that this particular progression sequence is an arithmetic progression. So the way we're going to do this is we're going to use our condition up here. So we're going to go, okay, well, T3 is equal to, T2 is equal to, and T1 is equal to. So let's identify what the third term is. Okay, the third term is just 186. The second term is going to be 193, and my first term is 200. Okay, so if I want to show that an arithmetic progression is, a sequence is an arithmetic progression, what I need to do is show that T2 minus T3, T3 minus T2 is equal to T2 minus T1. So let's do T3 minus T2. That's just equal to, well, T3 is 186 minus 193, and that gives me -7. Okay. Then we also want to check about T2 minus T1. So T2 minus T1, let's just have a look. T2 is 193 minus 200 for T1, and so that's also -7. So therefore, T3 minus T2 is equal to T2 minus T1. Therefore, the sequence is an AP. So there we go. That's how we show that a particular sequence is an AP. If there's a common difference between consecutive terms, that means that we have an arithmetic progression. Okay, so that's this first part done. We've shown that it's an arithmetic progression. Next thing that we want to do is we want to find the formula for the nth term. So if you have a look up above, the nth term formula is A plus, I'm just going to write here, so this is for the second part, Tn is equal to A plus n minus 1 times d. Now we've actually already found a few things. All we need to do here is just put in a few values. The first one is A. Now, at the beginning, we set up some notation. A is just the first term in my sequence, or T1. So if you have a look, T1 is just going to be 200, and I've already got that here. So what I can write here is this is just equal to 200 plus n minus 1 times the common difference. Now the common difference we've also found because the common difference is just when we subtract 2 consecutive terms. And so here, T3 minus T2, that gave me -7. And so here, for my common difference, that's just going to be -7. Okay, and we can start to simplify this and we'll actually get a simpler version of our formula. So here, this just becomes 200 plus, well, -7 times n, n gives me -7n, plus -1 times -7 means +7. And so here I get 207 minus 7n. So that's our formula to actually figure out our nth term in our sequence. So here, this is Tn, 207 minus 7n. And so we've done this second part, found a formula for the nth term. Okay, the next step is I want to find the first term, which is first negative term. So what we want to do is we want to figure out when this sequence becomes negative. So the way that we can do this, and if you remember from last lesson, we can just go to, if something is negative, that means less than 0. So we can go 207 minus 7n is less than 0. I also showed you that I prefer doing it as equal to 0. Let's just try doing it this way. And once again, we just need to test those 2 values that our number falls between. So here, let's just solve this. So we need to move that 207 to the other side. So I've got -7n is less than -207, and because we've got negatives on both sides, we can divide by, we've got that -7n, I can divide by -7n, but when we divide with a negative, remember the inequality flips. So n is greater than 207 over 7. Now 207 over 7, let's just figure out what that is. 207 over 7, that gives me 29.57. So this is equal to 29.57. And so what we need to do is we need to check for the 29th term and the 30th term. So let's just do that. T29 and T30. Or T39, I just sub in 29 into my equation here. So that's going to be 207 minus 7 times 29. 207 minus 7 times 29. That gives me 4. That's still positive. So let's check the next one. What happens if we get a 30 here times 30? That gives me minus 3. So 207 minus 7 times 30 gives me minus 3. So therefore, t30 is equal to negative 3 is my first negative term. So there we go. That's how we can answer all three of these questions here. So important things to note from this question: if we want to show that a sequence is an AP, we subtract two consecutive terms. So here, take t3 minus t2 and t2 minus t1, and we want to show that those two are equal. The value that we get from here is also the common difference, which will actually help us in the following parts. If we want to find a formula, the second thing was if we want to find a formula for the nth term, we use this Tn formula. The nth term is equal to the starting term, a, plus n minus 1 times d, the common difference. And so we can, once we found those values, we can sub it in and we can get an equation for our common term, our nth term. And just like we did last lesson, we figured out how to find the first negative term as well. Okay, let's have a look at the next example. Next one, show that log base 5, 6, log base 5, 12, and log base 5, 24 is an arithmetic progression. So here, just like before, in order for us to show that something is an arithmetic progression, we need to go t3 minus t2 is equal to t2 minus t1. So let's just identify our terms. So t3 is just log base 5, 24, t2 is log base 5, 12, and t1 is log base 5, 6. Now here we don't actually need to find any equation for the nth term, we just need to prove that it is an arithmetic progression. So here, the way we do this, we're just going to check t3 minus t2. Now t3 minus t2, if you have our look at our terms, that's just going to be log base 5, 24 minus log base 5, 12. Now, if you remember from when we deal with logs, if we subtract logs, what do? Well, when we subtract logs, that's just the same as dividing the thing that we're taking the log off. So this is just going to be the same as log base 5, 24 over 12, which is just log base 5, 2. Okay, so we've got the common difference of we've got the difference of term 3 and term 2. We need to do the same for term 2 and term 1. So here this is going to be log base 5, 12 minus log base 5, 6. And so when we subtract logs, we divide. So here this is going to be log base 5, 12 over 6. So that's log base 5, 2. So therefore, t3 minus t2 is equal to t2 minus t1. And therefore, AP. We've got an arithmetic progression here. So here for this example, we're just using the same condition for a AP. But we're dealing with some logarithmic functions, and we have to recall our log laws to actually help simplify this example. Okay, that's this example. Let's have a look at the next one. Now this one is where we need to use a little bit more thinking and a little bit more problem solving skills. Let's have a read. The third term of an AP is 16 and the 12th term is 79. Find the 41st term. So let's just break down the question what we have here and write it down. Now, first one is the third term of my AP is 16. The second piece of information that we have is that the 12th term is 79. Now, we know that this is an AP. So because we know that it is an AP, what can we do with this information? Well, because we know that it's an AP, that means that all the terms are going to follow a plus n minus 1 times d. So that's my terms in the AP. Any term in my AP is going to follow this pattern. So what we can do is just sub in the values that we have here. So let's start off with the red one. Well, the third term, that means I can sub in n is equal to 3. So here, t3 is equal to, and that's going to be equal to 16. So using that, I can go, okay, cool, 16. So I can just, from here, I can write this as a plus 3 minus 1 is going to be 2. D is equal to 16. So this, I subbed in that 3 into here. So here, a plus 3 minus 1. So I've got a plus 2d is equal to 16. The second one is I've got the 12th term is 79. So t12 is equal to 79. So using that information, I can go, okay, a doesn't change, but I can change n. So that's just 12 minus 1, which is 11d. That's going to equal to 79. And now that I've got this, I've actually got two equations I can solve simultaneously. So notice here, I've got equation 1, I've got equation 2. I'm going to write this down over here. So a plus 11d d is equal to 79, and a plus 2d is equal to 16. So those are my two equations. And what I can do is I can actually use these two equations and solve for a and d, and I can actually get a general term for my sequence and then figure out what my 41st term is from there. Okay, so let's actually go about doing this. So if you have a look at this, what method should we use? Well, if you have a look, both of these equations have a's in them and they both have the same coefficient. So what I can do is I can just eliminate it by going 2 minus 1. So I'm going to subtract the first term. I'm going to subtract for the first equation from the second one. So here, if you have a look, I'm subtracted and the a's disappear. 11d minus 2d just gives me 9d. And I subtract the 2 here, so I get 79 minus 16 gives me 63. And so therefore, that tells me that my common difference is 7 when I divide the 9 over. Using that, I can sub d is equal to 7 into one of my equations. I'm going to sub it into 1 to make it easier. So a plus 2 times 7 is equal to 16. That's 14, so a plus 14 is equal to 16. So therefore, a needs to equal to 2. And so from here, that means, so I'm going to go, therefore, Tn is equal to, so I sub these values in. So the starting term was 2 plus m minus 1 times the common difference of 7. And so my general term of my arithmetic progression just becomes 2 plus 7n minus 7, which is just 7n minus 5. So from here, I figured out what the nth term in my arithmetic progression is. What do we need to do as a final step? We want to find the 41st term. So all we need to do is just sub in n is equal to 41. So T41 is equal to 7 times 41 minus 5, 287 minus 5, and that just gives me 283. So there, 282. Whoops, my bad. 282. And that's how we can use this, solve this question. So for this one, we actually don't get told our first 3 terms, which makes it a little bit trickier. So for this one, we can just use our nth term in our arithmetic progression formula. So here, this is just the nth term in my arithmetic progression is Tn is equal to a plus n minus 1 times d. And then from there, we can sub in our two pieces of information. The third term is 16 and my 12th term is 79. And using that, we could have formed 2 simultaneous equations, which can then be used to solve this, figure out what a and d are, and using that, I can go back and solve and sub that into my nth term formula and figure out what the 41st term was from there. So that's it for today's lesson, Year 12. Let's just do a quick summary of what we talked about today. In today's lesson, we talked about what arithmetic sequences were. And arithmetic sequences were where you have a common, the terms differ by a common difference. So every time we go up in to my next term in my sequence, I go up or down depending on your common difference by your common difference. And so here we had a formula for the nth term in our arithmetic progression, which is Tn is equal to a plus n minus 1 times d. Now, I haven't actually checked this, but I think this might be on your formula sheet. I should have prepared this in advance. And this is on your formula sheet. This is actually on your formula sheet, so you don't need to remember this formula. This is a do not need to remember on formula sheet. However, the condition to test if something is an arithmetic progression is not on your formula sheet. So you need to actually know what the test for an arithmetic progression. So for us to test out an arithmetic progression, we just need to show that two consecutive terms are the common difference between 2 consecutive terms are equal the whole way through our sequence. And so that is what we did in these examples here, and we could actually work backwards and figure out what the sequence was if we could got given certain terms. So that's it for today's lesson. We're going to be going through a few examples of this on our online lesson tomorrow. Hopefully I'll see you guys then. But as always, Year 12s, stay safe, stay healthy, and stay wonderful, and I'll see you online. Bye!